Hello, everyone. This is the continuation of the chapter Nuclear Physics. And in the last class, we talked about what is a nucleus made of and where the electrons are located, and some of the important terms such as mass number, atomic number, neutron number, and also we learned the definition of isotopes. Okay, so in this class, we are going to talk about some of the nuclear reactions and how to write the nuclear reaction equation. And also, we'll talk about radioactivity and the different types of emissions. Okay, so to begin with, we also wanted to learn this term, which is called as atomic mass. Atomic mass is the weighted average mass of an atom of the element in a naturally occurring sample. Okay, it is generally measured in atomic mass units, which is abbreviated as AMU. And normally, the atomic mass of the different elements are based on carbon. Okay, carbon 12 is actually used as a standard. And when you take carbon actually exists in three different isotopic forms: carbon 12, carbon 13, and carbon 14. Therefore, the average mass of all the carbons is going to be slightly higher than 12, which is going to be equivalent to 12.011. Okay, the instrument that you see right here is actually called as mass spectrometer. The use of the mass spectrometer is to find the atomic mass, or is to find the mass of a molecule or compound. Okay, so on what basis does it work actually? So if you have the compound with you and you want to find the mass of the compound, then you'll inject the compound here, and there is going to be a high energy electron beam that will be bombarding the molecule into different fragments. So the negatively charged molecules are actually negatively charged fragments are sucked out of the instrument, whereas the positively charged ions alone will travel through the instrument and finally will be detected at the end. Okay, so depending upon the average mass of it, depending upon the different mass of it, they will travel at different speed and reach the detector at different speed. So this is the basis behind the mass spectrometer. And when you combine all the fragments together, you can actually build the molecule and identify its structure. Okay. Now, nuclear force. Remember that the nucleus of an atom is actually extremely small and packed with a combination of neutrons and protons. Now, according to Coulomb's law, we know that the like charges repel each other. Therefore, the repulsive forces in a nucleus are huge and the nucleus should fly apart. But that's not the case that is happening with atoms. There must exist a third functional fundamental force that somehow holds the nucleus together. Okay, and this third fundamental force is actually electrons. So the electrons are actually around the nucleus, making the atom as a whole neutral. Okay, and this slide is something that we have already talked about. Okay, next concept is the radioactivity. Now, radioactivity, let me go into the definition of radioactivity. Radioactivity, also called as radioactive decay, it is a spontaneous process where a nucleus undergoes a change by emitting radiation. Okay, and this is another term, nuclide. It is just nuclide. It's just a specific type of nucleus. There are like different nucleus. Example would be uranium 38. It's a nucleus, and carbon 14 is a nucleus. Okay, and radionuclides are nuclides whose nucleus undergoes spontaneous decay, which is radioactivity. Okay, and generally substances that give off such radiation are said to be radioactive. Okay, and some more terms. Parent nucleus, this is the original nucleus before decay. Original nucleus before decay. And the daughter nucleus is the resulting nucleus after decay. Now, radioactivity is a nature of some nucleides which is going to emit radiation. But this was actually discovered by Marie Curie and her husband Pierre Curie, and they found out that radioactive nuclei can decay or disintegrate in totally five different ways, but the three ways are like really common. The first one is the alpha decay, the second one is the beta decay, and third one is the gamma decay. And let's see what are these. Okay, alpha decay is actually where a nucleus is actually converted into another nucleus. Let's say that this is a nucleus A. It is actually converted into nucleus B with the emission of an alpha particle. An alpha particle is actually going to be similar to it's going to have the weight that is comparable to a helium nucleus. Okay, and beta particle or beta decay is when a nucleus is converted into another nucleus with the emission of the beta particles. Particles is going to be basically an electron. Okay, so which has this symbol. And gamma decay occurs when a nucleus emits a gamma radiation. So here in this case, the nucleus is going to be the same. In this case, in all of these cases, in alpha decay, the nucleus A is converted into nucleus B, and even in beta, nucleus A is converted into nucleus B. But in gamma decay, nucleus A is still converted into nucleus A, but then there is some amount of radiation that is limited during this reaction. Okay, and that radiation is actually gamma radiation. Okay, so these are the three different types of radiation that could be emitted from a radioactive material, and the alpha particles are actually positively charged and the beta particles are negatively charged, whereas the gamma particles have no charge. So they did the experiment where they actually put the two plates and the alpha particles were deflected towards the negatively charged plate, taking into consideration that they found out that they are actually positively charged. And similarly, the beta particles deflected towards the positively charged plate. So they